Hi, brief calculus students. I got this question from a student. I read the book and I can't figure out the right and left sums of integration. Well, let's say you're trying to define the area under a curve between 1 and 5, and you're asked to divide this into two areas. Okay, we just chop it into two areas. And the reason we do that is because we can make rectangles, and finding the area of rectangles is very easy. Let's say we come from the right side. So we need to know the values from the function, and then we just go ahead and come on over, and I'll go ahead and remove that curve. We just have rectangles left. They were two. This one on the left was 2 long, 4 high. The one on the right was 2 long and 1/2 high, which gave us some areas of 8 and 3. So our right-hand sum is going to be 11 square units. And you notice it doesn't approximate the whole area very well, but it's a good approximation for 2 boxes. If we came from the left, we just find the values from the left and come over, and we'll have some rectangles. Let me take care of the curve, and we just look at the area of these rectangles right here. Okay, so we're going to come up with 15.5 square units. Now this one's got a little gap here, and it's got it's kind of overlap here. So somewhere between the right-hand sum and the left-hand sum is probably a really good average. It's a really good approximation. Well, let me take you to a website published by David Little at Penn State University. He has an applet that will approximate with left-hand sums, right-hand sums, a midpoint, trapezoidal, and Simpson's rule. We'll just stick with left and right in this brief calculus class. So let me bring that up. Okay, so right now I typed in this function x cubed minus 5x squared plus 6x plus 1. And we're interested between 0 and 4. Okay, if you just look at two areas, say, well, we come from the left, come over, boom, come from the left, come over. If we did it from the right, we've got a slightly different area. If we move it up the number of boxes, okay, let's try 10. 10's good. You notice we keep coming right and over, right and over, right over, right over. We have all these areas. If we came from the left, we have left, over. See how we're coming from the left, over, all the way. You don't switch sides. It's always from the left or from the right. Then you get your areas here, and it's probably in between those two. And you can bump it up. See how this is probably pretty close. We'll have some overlap or leftover and some left over. But we're getting some pretty good approximations here from the right and from the left. You notice right and left are getting very, very close. You can change your function. This is a cool applet. I just take off the 1. Okay, and now, well, we're going to have a little negative piece because we went under the curve, but it's still going to work right here.